Hey everyone, and welcome to this explainer brought to you by Forge College. If you've been a developer for more than a week, you've definitely uttered the most famous last words in software engineering. Well, it works on my machine, right? We've all been there, right? Everything is running absolutely perfectly locally, but the exact second you push to testing or production, you're suddenly fighting these chaotic 2 a.m. bugs that make absolutely no sense. Well, today, we're going to fix that. As part of our broader track on programming with Solana, we're diving into patterns for client interaction setup. We're going to transition your code base from that really brittle, works on my machine state into a highly robust architecture that actually survives the real world.
Here's our blueprint for today. We'll start with the connection setup dilemma, compare singletons versus per-request patterns, look at factories and dependency injection, add in caching and retries, and finally, help you choose the right pattern.
All right, let's jump right into Section 1, the connection setup dilemma. Think back to our previous lesson, Basic Usage of Solana Client Libraries. In that one, we successfully executed a signed transaction. Locally, it worked flawlessly. You pointed your client to an RPC endpoint, configured your key pair, and boom, absolute magic. But here's the million-dollar question. Why does that exact same code often burst like bad plumbing when you drop it into an automated continuous integration or CI environment? The answer actually lies entirely in how your code consumes environment variables and how it physically holds onto that Solana RPC connection.
The absolutely crucial concept we have to tackle here is reproducibility. And reproducibility completely breaks down if you aren't deliberately managing how your program constructs its connections. Think about it. If your code secretly holds on to an old developer endpoint, but your testing suite is desperately trying to point it to a local test validator, you're going to get non-deterministic test failures. It's a complete debugging nightmare. We need total control over exactly when and how our environment config is sampled.
Moving right along to Section 2, singletons versus per-request setups.
Let's put the two most extreme wiring patterns head-to-head here. On one side, we have the singleton pattern. On the other side, the per-request pattern. Basically, a singleton is like a stubbornly welded pipe. Once you put it in place, the water is only ever going to flow that one specific way. A per-request pattern, it's more like a resource-hungry goldfish with zero memory. Every single time it needs to do something, it acts like it's experiencing the world for the very first time. Let's break down what this actually means for your code.
First up, the singleton. It lazily initializes a module-level connection variable exactly once. Honestly, this is fantastic for reducing overhead. If you're running a long-lived service, reusing that lightweight web3.js connection object is great because it gets to keep its internal caches. But, and this is a massive but, singletons capture the environment state at that first initialization. If you're running a test suite and dynamically change the RPC URL environment variable halfway through, the singleton literally won't notice. It is incredibly brittle for dynamic testing.
Now contrast that with the per-request pattern. Every single time your code makes a call, it parses the environment variables all over again and creates a brand new connection object. It immediately honors live environment changes, which, you guessed it, makes it absolutely fantastic for isolated tests. But remember our goldfish? It forgets any cache data, it creates a heavy resource drain, and if you have a busy application, constantly opening new connections as a one-way ticket to triggering RPC rate limits.
So, we need a better way. Let's look at Section 3, factories and dependency injection. Enter the factory pattern. This is a real game changer. A configuration-driven factory centralizes the parsing of your environment variables, things like your RPC URL and your commitment level. Instead of reading your environment state scattered randomly across 50 different files, you read it in one single dedicated place. Plus, your factory can intelligently fall back to sensible defaults like DevNet if an environment variable happens to be missing. It gives you predictable, totally deterministic behavior. And the factory pattern brilliantly paves the way for dependency injection, or DI. Instead of having your function create its own connection out of thin air or pull it from some messy global state, you simply pass the connection into the function as an argument. By doing this, you're completely decoupling your RPC usage from the connection creation itself. In a CI environment, you can now seamlessly inject a mock connection that simulates transient network errors or swaps out endpoints entirely, all without touching a single line of your core business logic.
Let's level this up in Section 4, adding, caching, and retries. We want bulletproof code, right? So here is a highly logical workflow for our robust, reusable client factory. Step 1, read the environment config. Step 2, take that parsed RPC URL string and use it as a cache key. We check our cache. Do we already have an active connection for this specific URL? If we do, awesome, use it.
Step 3, if not, we instantiate a new connection and instantly save it to that cache. And finally, step 4, we wrap our calls so that if we hit a transient network error, like a random blip, we gracefully retry instead of immediately crashing.
A quick, friendly warning here, though. Please do not try to force the lightweight Web3.js connection object to handle deep HTTP internals. Seriously, don't try to hack the connection prototype to perform retries deep inside the library itself. Keep your retry and back-off logic explicitly at the call layer, or just write a simple, clean wrapper around your RPC calls. We want to be smart here, not unnecessarily clever and complicated.
All right, wrapping up with Section 5, choosing the right pattern.
Let's look at how these stack up in the decision matrix. The singleton has a low initialization cost, sure, but the reproducibility and testability are pretty poor unless you're explicitly injecting it. It's really only suited for those stable, long-lived services. Per request is great for quick, short-run command line tools, but the performance cost is just too high for scale. But check out the bottom two, factories and dependency injection. They have a moderate init cost, but they offer deterministic behavior and absolutely excellent testability. For any serious CI-heavy workflow, factories and DI are your undisputed winners.
Before you commit to your architecture, just run through this quick checklist to make sure your code behaves perfectly across every machine. First, explicitly document exactly where and when your environment variables are captured. Second, provide test hooks or a clean DI interface so your test suites can easily supply mock connections. Third, centralize that retry and back-off logic so it's not duplicated everywhere. And lastly, ensure your CI scripts and container entry points align perfectly with your test wiring.
And here's the best part. These concepts aren't just for TypeScript. In our upcoming track, we'll be tackling Rust client development. The exact patterns we just explored map beautifully to Rust types, like the RPC client. You're going to use this exact same engineering mindset to figure out how to cleanly construct and inject your Rust clients.
I want to leave you with this somewhat provocative thought. Is your connection wiring truly reproducible? Or are you literally just one tiny environment variable tweak away from the whole thing breaking down? Take a hard look at your code base today, apply these patterns, and those 2 a.m. production bugs are going to become a thing of the past. Thank you so much for hanging out with me in this explainer made by Forge College. Be sure to head over to our website at forge.college to dive deeper into this subject and explore a massive world of other Web3 related topics. Keep building, stay curious, and I will see you in the next one.